Okay, let's work some problems now from section F of chapter 7. Again, working with the practice exercises. This problem asks me to compare two statements to see if they're logically equivalent. So first, let's think about what that means. If I'm told that two statements are logically equivalent, what that means is they are true or false together. So if one's true, the other's true. If one's false, the other is false. All right? That's logical equivalency. So what I want to do here is I want to construct a truth table, do it so I can see side by side the truth values for each of the statements, and then see if the main operators are always true in the same row or always false in the same row. If they are, then they're equivalent. If not, they're not. So let's start with the first one. I am told to evaluate these two complex statements. First, not P or Q. Okay, not P or Q. And then second, not P and not Q. Okay, we're going to see these in fact are equivalent. I can tell that already. This just says that this disjunction is false, and we know that disjunction is false only if both disjuncts are false, which means that P must be false and Q must be false. So these are going to be saying the same thing, just in different ways. This one's actually going to be important to us later on when we're doing proofs. There's going to be a rule that connects these kind of expressions. But let's just go ahead and prove that these are equivalent using a truth table. So I have two simple statements here overall. Both the complex statements are just about P and Q. So I'll use P and Q. Right? And then I'm going to need 4 rows. Right? The first statement, again, is not P or Q. I'll go ahead and divide that from the next statement. Not a very good truth table in terms of my lines, but hopefully it's good enough. The next one is not P and not Q. Okay? So let me go ahead and fill in my truth values. Again, this is filled in for you with the exercises, but true, true, false, false, true, false, true, false. I'll go ahead and fill them right over here as well. True, true, false, false, true, true, false. False is both the P's and the Q's. Oh, I forgot to print these here. Okay. True, false, true, false, true, false, true, false. Okay, let's start with this one. Okay, so I have the tilde outside the parentheses, and then I have the disjunction inside the parentheses. Always start within the parentheses in this kind of situation. So the disjunction is true whenever P is true or Q is true. So to compare them here, I just need to look for whether I see a T on either side. I do here, I do here, I do here, I don't here. Okay? So that is the value of the statement inside the parentheses, and the negation just is the opposite of that. So when the disjunction is true, negation is false, and on this last row where the disjunction is false, the negation is true. So false, true, false, 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 true. Okay, that's the main operator here, so I'll go ahead and mark that. You would need to select it in your exercise. Now I'll move over to this other one. You can hardly see my dot there. Let me put that in better. Okay, here I have a choice between, I have the tilde, I have the dot, and I have the tilde. When you have a choice between tilde and another operator, always start with the tilde. Do I start with the not P or not Q? It actually doesn't matter, but I'll start going left to right, so I'll start with not P, right, and then we'll do not Q, and then we'll do the and. So not P is just the opposite of what you see for P, so false, false, true, true. Not Q is just the opposite of what you see for Q, so false, true, false, true. And then for the and, I need to compare the value under this tilde with the value under that tilde, and is only true when both are true. So false and false gives me false, false and true gives me false, true and false gives me false, and true gives me true. That's my main operator, so again, I will circle that, you will select it. And now I compare them. On row 1, false, false. Row 2, false, false. Row 3, false, false. Row 4, true, true. They are always having the same truth values, and so I'll be a little lazy here and just abbreviate logical equivalence. Okay, hope that helps.